Okay, today we're going to be going through the 2022 Paper 2 of the Edexcel GCSE Maths exam. So let's get into it. Feel free to pause the video at any of these questions and have a go yourself. We'll be going through all the answers and work solutions. So question 1 then, the scatter graph shows information about the amount of rainfall in millimeters and the number of hours of sunshine for each of 10 English towns on the same day. You can see we've got a nice graph here. One of the points is an outlier. Write down the coordinates of this point. So if you look at this graph, what we should be able to see is that if we had a ruler, and I don't have one, but you guys should have one, but if we just zoom out a little bit, if we take a ruler over here, what we'd be able to do is draw a line of best fit through these points over here. And you can see, obviously, it should be a straight line, but one of the points doesn't really fit in this pattern, and that is this point over here. Okay, so this is your outlier. And so in the question, I'll ask you to write down the coordinates of this point, so we can go ahead and do that. And if you look, it's 2 across, and it's midway through this marking over here. So that's because that marking is 2 and it's midway through, then it's 1 up. So we put 2 and then 1. You should know the order that you write your coordinates, x coordinates first and then y coordinates. So that's the first question done for 1 mark. Part B, ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. And again, this is just a 1 marker, so we just need to basically say what's happening over here. And as we can see, as the amount of rainfall increases, the amount of sunshine decreases, or the number of hours of sunshine decreases. So you can say something like that. So what we could write for 1 hours, as rainfall increases, number of hours of sunshine decreases. Okay, and you write it in words like that. Okay. On the same day in another English town, there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town on this day. So again, we're going to go to our graph. We're going to estimate using our graph. So here you'd have to draw your line of best fit. Try to draw a better line than this because you should have a ruler. It said that basically we had 7 hours of sunshine, I think. Yeah, 7 hours of sunshine. So we go to our 7 over here, which is on our y-axis. And then we go across. You go to where it meets the line, and then we drop a line down all the way down to our x-axis, and we read off of here. Now, my answer might not be completely accurate because my line isn't completely accurate, but I get approximately 2 I think that's 2.8. But you can say maybe 3, okay? If your line was a bit better, maybe you'd get something slightly different. And I think in the mark scheme, it's expecting a range of 3 to 4. So you should get that if you use a ruler for your line, okay? Question 2, then the front elevation and the plan of a solid are shown on the grid. On the grid, draw the side elevation of the solid from the direction of the arrow. So it's a bit of a geometry question here, but it's kind of more common sense than anything else. So the first thing you were looking at is the front elevation. So this is what the it would look like from the front, right? So essentially it tells us the different heights that we're working with. Now the plan elevation gives us instead, basically, if we were looking top down, what we would see, and you can see it's 3 across there, and you got something across there as well, and you can see those line up like that, which you would expect because that's looking at it from the front, and this is looking top down. Okay, so then we're asking the question, okay, if we're looking from this angle, what would we see? And we want to draw the elevation for that. So if we're looking from the side, then the height is going to be dictated by the tallest point of the building, right? So this is basically the length of this side over here, which you can see is 1, 2, 3, 4, 5. Okay, so when you're looking from the side, this is what you'd see. You'd see an object which is 5 high. 1, 2, 3, 4, 5. Your elevation would be 5 high. Now, how wide is it going to be? This is where you need to use the plan. So because the plan is 3 wide, then essentially, if you're looking from the side, you'll see the rectangle with a width of 3. So you can go ahead and draw 1, 2, 3, and then basically just join that up into a rectangle like this. And obviously use a ruler, but essentially that is what it should look like. Okay, so let's move on. Question 3 then, here are the first 5 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of this sequence. So a nice interesting question here. We're working with nth terms. Hopefully you guys are familiar with working with nth terms. So the best way to do this is if you look at the jumps between each of our numbers in our sequence, you'll notice that the jump each time is 6. And so you can start off with 6n. And then when n equals 1, then you should get 7. So you need to add 1 to this. And then you can check that that pattern works for all of them. So when n equals 2, so this is 1, this is when n equals 2, you should get 13. And so you check that that works. 6 times 2 will get you 12, add 1 gives you 13, okay? And this is not the correct way to write this, but you get the idea. So essentially, yeah, your arithmetic sequence then in terms of the nth term would be 6n plus 1, and that's what you'd write down as an answer. Okay, next part, the nth term of a different sequence is 8 minus 6n. Is minus 58 a term of the sequence? You must show how you get this answer. So some minus 58, so you're right, minus 58 is equal to 8 minus 6n. And basically, if n comes out to a whole number over here, then essentially you know that minus 58 is going to be in the sequence. And if it's a fraction or a decimal, then basically you're saying that n has to be a decimal for 58 to ever be in, or minus 58 to ever be in the sequence, which can't be, therefore minus 58 is not in the sequence. So we can go ahead and rearrange to work this out. So minus 58, we can minus 8 from both sides. So minus 58 minus 8 is going to give you minus 66. And that's equal to minus 6n. And then minus 66 over minus 6 will give you n. And you can work that out. That is going to be 11. Okay. So here n is 11. And so what you can say is that basically this is part of the sequence. So you'd write yes over here. Okay, let's move on. Question 4. The diagram shows a plan of Jason's garden. ABCO and DEFO are rectangles. CDO is a right angle triangle. AFO is a sector of a circle. The center O and an angle AOF equals 90 degrees. Jason is going to cover his garden with grass seed. Each bag of grass seed covers 14 meters squared of garden. Each bag of grass seed costs £10.95. Work out how much it will cost Jason to buy all the bags of grass seed he needs. Okay, so basically we need to work out the area of the shape and then work out how much it's going to cost to cover all of that area. Okay, so the first thing that we can do is work out the area of the easy bits. So we've got a square here, or a rectangle here, and another rectangle over here. So very simple to work that out. Hopefully you just do 9 times 7 for the first rectangle, and that should give you 63. And you do the same thing over here, 11 times 7, and that should give you 77. Perfect, so we've got 2 of them now. Then we can use a formula to work out the area of this triangle. That's going to be half times the base times the height. So the base is going to be this length over here, which is 11. It's the same length as up there. So half times by 11 times by the height, which is going to be the same as this length over here. So that's going to be 9. And if you put that into your calculator, you should get 49.5. Okay, great. So we've got almost all of them. We're just missing now this sector of our circle, basically. So it seems like a quarter circle. So what we can do is we can use our formula for a circle and then divide by 4. So we can do pi multiplied by r squared. And r in this case is going to be 7 because it's just use a different color, but it's this length over here, which is equal to 7. Also this length over here, which is equal to 7. So pi times 7 squared. Well, that would give us the area of the whole circle, but we've got a quarter circle, so you can divide through by 4. And so if you put that into your calculator, you should get something like 38.4845 and so on. And the one thing is, don't round this just yet. Keep it to as many decimal places as you can, and then we'll round it all at the end. Okay, so now we've got essentially all the different parts of our shape, and we can work out the total area. So basically what you want to do is add all these individual areas up, and if you put that into a calculator, you should get a total area of approximately 227.9845, so on. And again, we don't want to round it just yet. We want to keep it to as many decimal places as we can. Okay, so now we've got the total area, and we're told that each bag covers 14 meters squared. So how many bags do we need to cover the whole area? So you just do 227.9845 divided by the number of, the amount of area that one bag covers, which is 14 meters squared. And if you put that into your calculator, you should get that you get approximately 16.28 bags. And if you need 16.28 bags, then basically the total number of bags that you need is going to be 17, right? Because you can't buy a fraction of a bag, so you need to round this up. And you can't round it down to 16 because you won't have quite enough, because you need a little bit more than 16 bags. So you need 17 bags total. And then all you do then is take your 17 and you want to find out the total cost. So the cost per bag, £10.95. So you just do 17 multiplied by £10.95. And it should come out to £186.15. Okay, and yeah, you can put it down there. And that's it for that question. Okay. Question 5, work out the value of x. So we're given a triangle basically, and so you can just use a formula here. So this is a simple trigonometry question, and so we have the hypotenuse, And we also we're trying to work out the adjacent angle, right? Because it's this would be the opposite because it's opposite angle. So essentially we've got the cosine rule over here, so we can say that cos of the angle, or in this case 53, is equal to the adjacent, in this case is x, over the hypotenuse, in this case is 14.5. And then you can just rearrange for x, and so x is equal to cos 53 times 14.5. And so that's nice and simple, you just put that into your calculator. Okay, and you should get approximately 8.73. Okay, and it's 3 sig figs, so whatever you get, make sure you round it to 3 significant figures. So yeah, that's what it would be. Question 6, Elliot invests £7,000 for 2 years in an account paying compound interest. In the first year, the rate of interest is 3%. In the second year, the rate of interest is 1.5%. Work out the value of Ella's investment at the end of 2 years. So very simply, we just take our £7,000 that we started with. Then in the first year, to work out the total, you multiply this by the multiplier, basically. So if it gains 3%, then you multiply the total by 1.03. So multiply 1.03, that would give us the first year. And then basically we can take a shortcut and we can just multiply this by the second year total as well. So again, the multiplier over here would be 1.015, okay? So that's just a case of converting your percentages to multipliers. Essentially, you'd have 103%, so that would be 1.03, and 101.5%, 1.015. Okay, so if you multiply those two together, then you should get a total of £7,318 and 15 pence. Moving on, question 7. Here's a graph of y equals x squared minus 6x plus 4. So we've got a quadratic equation over here. And we're told write down the y-intercept of the graph of y equals x squared minus 6x plus 4. So you can just read this straight off from the graph, to be honest. And the y-intercept is when the x equals 0 and it intercepts the y-axis. So that you can see that it's going to be essentially y equals 4. So you can write down there, 4. Write down the coordinates of the turning point of the graph of y equals x squared minus 6x plus 4. So again, just go over here and you can see the turning point. That's the point where it actually turns. And the coordinates would be along the corridor 3 on the x-axis and up the stairs minus 5. Okay, so you can write that down. And the last one then, use the graph to find estimates for the roots of x squared minus 6x plus 4 equals 0. So when we find the roots of an equation, essentially you set it equal to 0 and you find when that is going to be what x equals when y equals 0, basically. So when y equals 0, you can see it crosses the x-axis. That's basically what the roots are. And so you can read this off of the graph. Feel free to zoom in and read it for yourself. But essentially, you should get an answer of approximately 5.1. And the second root would be 0.7. And there's a range given in the mark scheme. If you just read it off the graph, get anywhere between 5.1 and 5.3 and 0.7 to 0.9, you should get the marks. Okay, question 8. Chanda buys a necklace for £120. She sells the necklace for £135. Work out her percentage profit. And so this is just a simple percentage question. Essentially, the amount of profit she made was £15. You need to work out £15 as a percentage of what she paid. So what you do is you do 15 divided by the 120, and though her profit is going to be that, and work out as a percentage, you want to multiply by 100%. Okay, and if you put that in your calculator, you should get 12.5%. Okay. Next question then. Here are the equations of two straight lines. Oscar says that these lines are parallel. Is Oscar's correct? You must give a reason for your answer. Well, if two lines are parallel, then essentially the gradients of both lines are going to be the same. And to work out what the gradient of a line is, you can get it in this form, y equals mx plus c, where basically m would be your gradient. So we need to get both of these equations in the same form, in that format. Now the first one is done for you, so you can see the gradient of this is going to be a half. The second one, though, we have 6y, and essentially we need to make sure that y is on its own. So we can just rearrange that y is going to be equal to 3x plus 7 over 6. And then you can separate out this fraction. That is going to be 3 over 6x plus 7 over 6. And so essentially then you can see 3 over 6, that's going to simplify down to a half. So y equals a half x plus 7 over 6. And then you can see our gradient is going to be over here according to our form over here. And therefore they both have the same gradient of a half x. So yes, these lines are parallel. So you can say yes. Okay. Question 10. Alia bought a car. In the first year after she bought the car, its value depreciated at a rate of 23% per annum. In the second year after she bought the car, its value depreciated at a rate of 90% per annum. At the end of the second year, the car was worth £10,914.75. What was the value of the car when Alia bought it? And so essentially, it's just like the percentage appreciation that we saw with the compound interest, but now we need to do it in reverse. So we need to actually work from the second year first. So the second year depreciated at a rate of 19%. So at the end of the second year, it's worth this much. And so basically, this is going to be 81% of the value at the start of the second year, because we lost 90% of value, so we had 81% of the value left. So if you divide this by 81 and times it by 100, then we should get 100% of the value of what it was basically at the beginning of the second year or the end of the first year. So if you put that into your calculator, and this will give you 13,475. And then basically you do the same thing for the first year, but this time you have 13,475. And this represents, because it depreciates by 23%, then the value over here is going to be 77%. Okay, so this is basically 77% of the value that it started with. Okay, this number over here. And so we do the same thing. We can divide through by 77 to get 1% of the value, and then multiply it by 100 to get 100% of the value. And if you put that into your calculator, you should get an answer of 17,500. Okay, and that will be your final answer. Question 11. In an experiment, 60 students each completed a puzzle. The cumulative frequency graph shows information about the times taken for the 60 students to complete the puzzle. For these 60 students, the least time taken was 24 seconds. The greatest time taken was 96 seconds. On the grid below, draw a box plot for the distribution of times taken by the students. So the first thing we can do is add our whiskers on, basically. So 24 seconds. You need to basically just go along and find what 24 is. So let's zoom in to actually work this out. So this would be 30. And so 21, 22, 24, 26, 28, 30. So 24 would be the second square along over here. We can mark that on. 96, we go along over here. So this would be 90, 92, 94, 96. So we can go along and mark that one as well. Then we need to draw on essentially the lower quartile, upper quartile, and median. So we can use our cumulative frequency graph. So what we want to do is we want to say that there's 60 students that completed the puzzle in total. And so 30 students would be basically the median mark, right? So what we can do is go to the cumulative frequency, we go to 30 over here, and this would give us our median. And so we can drop a line down and read this off the graph, and that looks like it's going to be 54. So that's our median. Then if you want to find the upper quartile, we need to find basically the 3/4 mark over here. And so that's going to be equal to 45. That would be the upper quartile for 60. And so again, you go to your cumulative frequency graph and you go along until you find 45, which is going to be there. And you draw that along and you drop a line down. And again, feel free to use a ruler and do this a little bit more accurately than I am, but you should get about 64. I think my line went a bit off there, but it should be about 64. And then the last thing we want to find is the lower quartile using our graph. So again, we go to 60. The first quarter of 60 is going to be 15. And so we go down over to our graph, find 15 on our cumulative frequency axis. And we go across and we drop it down again. And you should get what looks like it's going to be 42. Okay, so we've got 42, 54, and 64 as our 3 points, our lower quartile, median, and upper quartile. And so we can draw those on as 42 over here, I think. Yep, 42, 44, yep. And then you want to draw 54. So 54 is going to be about there. And then finally, you want to draw on the 64. And so that's going to be about there. And then basically, it doesn't really matter how high you make your box plot. But essentially, you can elongate these a little bit, draw lines to match them up, and then draw on your whiskers like that. Okay, and that's your box plot. Question 12, then the number of insects in a population at the start of the year n is Pn. The number of insects in the population at the start of the year n plus 1 is Pn plus 1, where Pn plus 1 equals Kpn. Given that K has a constant value of 1.13, find out how many years it takes for the number of insects in the population to double. You must show how you get your answer. So essentially what's going on here is you have this constant K and you multiply that by the population in any year n, and that will give you the population of the next year. Now, if you then want to find the population of the year after that, then this is just going to be equal to the population of the next year. And so you just multiply that by k again. And you can see there's going to be a pattern over here. You multiply it by k again, however many times for however many years you want. Okay, so in the first year, after the first year, you're going to get this. After the second year, you're going to get k times pn, and third year is going to be like this. Okay, so you can see where this is going. Basically, your formula that you need is basically k to the n multiplied by pn is going to give you the population of n plus 1, basically. Essentially, this needs to double. So this is the population in some year x, we'll call it. And actually, this should be not n, but x, just to make it a bit more easier to understand. So x is the number of years that we progressed, and n is the initial year, okay, the start year. So essentially, we add on a certain number of years, and then to find out what the population would be, we raise k to that power and multiply it by the population of the nth year. And so essentially, what we need is pn plus x, so the population after x years is going to be divided by the population at the beginning is going to be equal to 2. So what you need is that k to the x is equal to 2, and you know that k is 1.13, so 1.13 to the x is going to be equal to 2, and so then you just need to work out what x is from here. And so the simplest way to do this is just by trial and error. If you plug in various values of x to work out essentially when 1.13 to the power of x is going to be equal to 2 or larger than 2. And so just to give you an example of what that would look like, I'll just do it over the side over here. 1.13 to the 5 is going to be equal to, if you put that into your calculator, I think you should get a 1.84. And so after 5 years, it's not quite enough. And if you do 1.13 to the 6, then you should get 2.08. So you can say after 6 years, it does double. And so your final answer would be 6 years. The value of k actually increases year on year from this value of 1.13 in year 1. How does this affect your answer to part A? And it's just a 1 marker. So essentially, how many years would it take to double if k increases? Where you can see from our formula, if k is getting bigger every year, then essentially it's going to decrease. Okay, the number of years it takes for it to double is going to decrease. Question 13, A and B are points on a centimeter grid. A is a point with coordinates -7, 6. B is a point with coordinates 8, -5. Work out the length of AB. Give your answer correct to 1 decimal place. So this is just a simple case of Pythagoras' theorem. So essentially, you've got what you have is a line, and we'll actually draw it on. I won't draw the coordinates on, but this is basically what you're working with. You have a line over here, and you're given a coordinate system. So using the coordinate system, you can work out the length of this line. You can work out the length of this line, and then if you add the squares together and square root it, you'll get the length of your line, which we'll call x. Okay, so to do this, then we can just use our coordinate system. It's quite handy to us. And so the first thing we can do is -5 - 6. And this is the basically the difference in the y coordinates. So one of the y coordinates was -5, one of them was 6. So to work out the difference, you do -5 - 6, and that would give you the length of the y value. And then we need to square that and add it on to the difference in the x values. So again, we start with 8, and we do -7, which is the same thing as adding 7. And we square that, and that will give us the length of the on the x-axis. And then basically, we need to square root that whole thing that we get. You can put that all into your calculator, to be honest. That's a bit of a shortcut, and you should get 18.6 centimeters. Okay, question 14. Using algebra, prove that 1.062 can be written as, 1.062 recurring can be written as 1 and a 14 over 225. So this is how we deal with basically recurring decimals. How can we still write them as fractions? So essentially, you take 1.062, and you can say that this is going to be equal to, actually it's easy if you do it like this. If you split this up to 1 plus 0.62 recurring. Then you can take this 0.62 and you can split it up. So you can say that x is going to be equal to 0.62 recurring. And we can basically, to make it a bit easier, we'll write this in with a trailing ... like that. And then 10x therefore is going to be equal to 6.222 ... like that. And then if you were to, and then if you were to take your your 10x and take away x, then essentially you can remove these trailing spaces because these basically cancel out. Okay, and so what you end up with, and actually it's a bit easier if you do this with 100x and 10x. So let's change this to 10x, this to 100x, and so these become very similar, but this becomes 6.2 dot dot dot, and this becomes 62.2 dot 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 dot. Okay, and that makes it a bit easier because then these can cancel out straight away. And so you got 62 minus 6, and so 100x minus 10x is going to be equal to 90x, which is going to be equal to, like we said, 62 minus 6, which should just give you 56. And therefore then we can rearrange for x. So x is going to be equal to 56 divided by 90, because 90x, remember, was equal to 56. And actually we just made a little mistake over here at the beginning, that actually should be written over here that this is not 0.62, it's 0.062. And that's where we went wrong, recurring. And so all of this then, this is not 10x, this is 100x. And this is not 100x, this is 1000x. And you can see where this is going. Therefore, we did 1000x minus 100x, so let's correct that. And you give 900x, and then this should be divided by 900. And then this does indeed simplify down to 1 and 14 over 225. Okay, so that's that. Question 15, Faiza is studying the population of rabbits in a park. She wants to estimate the number of rabbits in the park. On Monday, she catches a random sample of 20 rabbits in the park, marks each rabbit with a tag, and releases them back into the park. On Tuesday, she catches a random sample of 42 rabbits in the park. 12 of the rabbits are marked with a tag. Okay, so it's the catch-release method. Find an estimate for the number of rabbits in the park. So this is just a simple method which you should hopefully memorize. So the first thing I'm going to do is work out the fraction. So essentially we're saying that the initially she caught 20, and basically she tagged all of them. So there were 20 that she tagged out of the total number n, okay? And so whenever you catch a random sample, then the amount of tagged versus non-tagged should match this ratio or this fraction, okay? So then that's going to be equal to the number of tagged rabbits that she caught the second time round, okay, as a proportion of the total number. So she caught 12 tagged rabbits, and the total that she caught was 42, okay? So these are going to be equal. So using this, we can work out what n is, and n in this case represents the total number of rabbits. So n is going to be equal to 20 times by 42 divided by 12, and if you put that into your calculator, you should get an answer of 70. Okay, so that's stratified, well, not stratified, that's sampling. Albie is studying the population of rabbits in a wood. One day he catches 55 rabbits and finds out 40 of these rabbits are marked with a tag. Albie estimates there are 50 rabbits in the wood. Explain why Albie's estimate cannot be correct. Well, very simply, he caught 55 in the first place, so how could the total sample, the total population be 50? So the sample cannot be greater than the population. Okay, question 16. The shaded region shown on the grid is bounded by 4 straight lines. Find the 4 inequalities that define the shaded region. So basically, you just need to write the formulas for each of the lines, and that should give you the answers. Fine, because these lines are thick lines and they're not dotted lines, then you need less than or equal to's or more than or equal to's, okay, because the line itself counts as part of the shaded region. Okay, so the first and the easiest one to do is if you look at the top line, you can see everything has to be below 6 according to this line. So y is going to be less than or equal to 6. That's the first one. Then you can do something similar for the second straight line over here. So you can see y has to be, in this case we're working with x, so x has to be greater than or equal to minus 3. Okay, and then you just need to work out the formulas of your two lines that are at an angle. So for the first one, to work it out, basically you need to work out the gradient of the line. So let's just highlight one of the lines. We're going to work with this one, and remember we need we can write our straight line formula. So y equals mx plus c, and so c is going to be plus 6 because that's the y-intercept, and then m is going to be the gradient. So to work that out, you can see that as we go across by 2, we increase by 6. And so what we can say is that the gradient is going to be the difference in y, which was 6, divided by the difference in x, which was 2. And so the gradient here is just going to be 3. Okay, so our formula is going to be y equals 3x. And everything has to be to the left of this line. So basically what we're saying is that y has to be greater than or equal to 3x plus 6. Okay, so for the third inequality, that's what we'd write. And so we can just replace this with a greater than or equal to sign. Okay, and the way you can check that is basically you just go into the shaded region and check what y and x is, or just check what x is and what would y give you according to this formula, and what is y in the shaded region. Okay, you can work out that actually has to be larger than m. Okay, perfect. Then we just do the same thing for the second line. So let's clean this up. If we were to take this line, you do the same thing like we said. So you can once again work out the y-intercept is going to be 1 this time. And the gradient, you can take as much of the triangle as you want. And so we'll just take this little section because it's easiest. It's a straight line, so the gradient will be the same the whole way through. So the difference in x is 2 and the difference in y is 1. So basically you get a gradient of a half, okay? So again, y is going to be equal to half x plus 1. And again, if you work it out, you can see that everything has to be basically above this line. And so again, we want to put y has to be greater than or equal to a half x plus 1. Okay, so that's the 4 regions that would define this, and you write them all down there. Okay, question 17, then we're looking at 2 solid triangular prisms, A and B. We're told the volume of prism A is that, and prism B is that. And we'll screen up the scribble so you can see it. The cross-section of each prism is a right-angled triangle, and we're given the length and the area of the right-angled triangle in prism B. Okay, the height of the triangle for prism A is h centimeters. Work out the value of h. So the first thing we can do is basically recognize that these are 2 similar solid triangular prisms. That means that the ratios and proportions of the lengths are going to be similar. So what we can do is, well, they're going to be the same because they're similar triangular prisms. So what we can do is work out the ratio of the volumes. So the easiest way to do that, you take 1587.762, divide it through by 58.806. And if you put that into your calculator, you should get that the scale factor is going to be 27. So basically prism B has 27 times more volume than prism A. Okay. The next thing we can do is, essentially the reason why I wanted to work that out, we could use this scale factor to work out what h would be if we can work out the height of B, right? If we go in reverse, we can use a scale factor because we know that proportionally they're going to be the same, right? So let's try to work out this height over here then. So we can use Pythagoras' theorem for this, or in fact we can just use the area of a triangle formula for this because we got the base, and we know that the formula is a half times by base times by height is going to be equal to the area. And so we can plug in our numbers. 43.74 is our area. It's going to be equal to a half multiplied by 8.1 multiplied by our height. And we'll call this x since this is already called h. So yeah, multiplied by x. And in fact, we'll get rid of that. So 8.1x like that. And then we can just rearrange for x. So x is going to be equal to 43.74 divided by a half, which is the same as times by 2, and then divide through by 8.1. Okay, so if you solve that, then you should get, that x is equal to 10.8. Can write that down. Okay, now perfect. Then essentially we need to work out what to do with the scale factor. So if you were going from the volume of B to the volume of A, you saw the scale factor was 27, so you'd have to divide through by 27. Now, in this case, we're working with heights. So if we're working with heights, what we need to do is cube root the scale factor of the volume. Because essentially we went from centimeters squared with the area, so we'd have to square root to get back to that, and we'd have to cube root from the volume to get to just a simple length. So then all we do is we take that 10.8 and we want to divide through by the scale factor or the volume cube rooted, okay? And then if you put that into your calculator, you should get the final answer of about 3.6. And that's your value for h. Question 18, here is a triangle. Work out the area of the triangle. Give your answer correct to 3 significant figures. So this is just a regular formula question, which I think is in your formula book, but hopefully you know it anyway. So you just do a half multiplied by 11.2, so the length of one side, multiplied by 4.3, which is the length of the other side, multiplied by side of the angle. Okay, so you can use this even if it's not a right angle triangle. And if you plug that into your calculator, then you should get about 21.3. Okay, to 3 significant figures. Question 19, solve 6x squared plus 5x minus 6 equals 0. So nice and simple. Basically, it's a quadratic equation, and you can solve it by either trying to factorize it, or you can solve it using the quadratic equation. So like I said, either way will work. I'm just going to go ahead and factorize it. So if you do 2x and 3x like this will give you those 6x squared. Then you need 2 numbers that are multiplied to minus 6 and add to 5. And so I'm going to put plus 3 over here. and minus 2 over here. So yeah, 2x plus 3 and 3x minus 2. And you can check that this works because you get, if you multiply these together, you get your 6x squared. If you multiply these together, 3 and minus 2, you get your minus 6. And then in terms of the adding to 5, you need to account for the numbers in front of the x's over here. So here you'd get minus 4x, and here you'd get plus 9x, and that should give you your 5x, which you're looking for. So you can see that works. Okay, so now we've factorized it, then we need to actually solve for x. So what you should be able to say is that x is going to be equal, if you want to make this equal to 0, then essentially one of these brackets needs to equal 0 at each point. So if we want to make this first bracket 0, so actually the 2x plus 3, then in this case, x would need to equal minus 3 over 2, okay? And you can do the same thing for the second bracket. So in this case, then if you look at the second bracket, x would need to equal 2 over 3. And you can see that basically if you put 2 over 3 into this, then we'd get 2. And 2 minus 2 would give you 0. And so the whole thing would come out to 0. And the same thing for the top one. And so that's how you basically solve for this. So you get minus 3/2 and 2/3 would be your two answers over here. Question 20, ABCDEFGH is a cuboid. And we've got some lengths here. Work out the size of the angle FAH. Give your answer correct to the nearest degree. So let's go ahead and write these on. AD is going to be 13 and, AD is going to be 9. And F to D is going to be 13. And that's basically this long side over here. And we want to find FAH, which is basically this angle over here. Yeah, it's kind of 3D, so it's difficult to draw, but you can see what we're trying to do here. So the first thing we can do is work out the length of FA or AF. So AF is going to be equal to 13 squared minus 9 squared square root. Okay, so that's just Pythagoras' theorem. We've got the hypotenuse over here. We've got one of the sides over here. So we can use Pythagoras to work out what that is. And so we'll leave this in the square root form of root 88. Okay, so we don't want to start simplifying down yet or cutting off decimal places, because then we need our answer correct to the nearest degree. So we want to keep as much accuracy as possible. So we can write this on that AF is root 88. Then the next thing we want to find is essentially F2H, which we'll draw on a different color over here. So if we have F to H and AF, then essentially we'll have enough information to work out what that angle is. So what we can do then is work out what F to H is using the last bit of our question. So the angle GHF equals 49 degrees. So if you plot GHF, G to H to F is going to be this angle over here. And so essentially what we can do is drop down, there's a 9 centimeters over here to F to E. And then using our similar angles, essentially we can see that this is also going to be equal to 49 degrees. These are opposite angles essentially, or alternate angles. It's a Z-shaped angles. And so then here we've got a side and an angle, and we can use trigonometry to find out the length of then F to H. And so basically what we can say is that cos 49 equals adjacent over hypotenuse. And in this case, our hypotenuse is F to H. So cos 49 equal to adjacent, which is 9, over F to H. And then if you want to find F to H, then basically you need to rearrange. So it would be 9 over cos 49. And if you put that into your calculator, you can put it into a calculator. You should get like 13.7. And again, keep as many decimal places as you can. So we don't want to simplify it down just yet. Okay, so now we want to find the size of angle FAH, which we drew over here. So now we've got the length of FH, which is over here. We have also the length of AH. We also have the length of AF, which is this one over here. And so we should have enough information then to work out the size of the angle FAH. So essentially the tan of the angle is going to be equal to the opposite over the adjacent. That's your opposite, that's your adjacent. Okay, so you see we've got both of those, so we can just plug in our numbers. So tan FAH is going to be equal to opposite, which was the 13.7 that we worked out, divided by basically FH, divided by adjacent, which this time is our A to F, which we worked out, which was root 88. And then you basically going to do tan minus 1 of that, and you should get that the FAH angle is equal to 55 0.6 approximately. Okay, to 3 or to the nearest degree then would be rounded to 56. Okay. Question 21. The graph below gives a volume in liters of water in a container t seconds after the water starts to fill the container. Calculate an estimate for the gradient of the graph when t equals 17.5. You must show how you get your answer. So here we have a curved line and we're trying to work out the gradient of it. So what we need to do is to work out the gradient at a point, we just draw a tangent to the curve. So you go ahead and find 17.5 on your curve, which I think is going to be approximately somewhere over here. Feel free to zoom in, use a ruler obviously, and then basically take a ruler, line it up with the angle of the curve at that specific point and draw a tangent, which should look something like that, but a lot straighter. Then you can find the gradient of that by doing the difference in y by the difference in x. You can draw a triangle and work out what that would come out to. And again, use a ruler for all of this, make sure all your lines are nice and straight. I cannot use a ruler, so I will leave the rest of this question, but you should get an answer of approximately 0.1 to 1.2. Okay, describe fully what the gradient in part A represents. So let's look at the question. The question is telling us the graph below gives a volume in liters of water in a container t seconds after the water starts to fill the container. So filling a container, and the gradient is basically telling us, if you think about the units, it would be liters per second. So how many liters are you adding to the container per second? Okay, so basically it's the rate of change of the volume. That's what you'd write. Question 22, f of x equals a cube root of x. G of x equals 2x plus 3, h of x equals f g of x. Find the h minus 1 of x. So it looks pretty complicated, but actually you're just substituting one into the other. So f of x is cube root of x, and then we change the x over here to be g of x, because that's what our formula says, f of g of x. And so g of x was 2x plus 3, so this becomes cube root of 2x plus 3. You can see it's actually not that difficult. And that is equal to h of x. Perfect. And then all you have to do is find the inverse of h of x. So to find the inverse, we just want to get x on its own over here. So the first thing we could do is cube h of x, and that would be equal to 2x plus 3. So I've just switched the sides here. Then essentially you want to take, so this would be all of h of x, by the way. And then essentially you can minus 3 and then divide by 2. So h of x all cubed minus the 3 divide by 2 will give you x, and then here you can just replace your symbols basically. So this now becomes x cubed minus 3 over 2, and this would equal to the inverse of h of x. Okay. And then 23, a race is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 kilometers. Sam runs the race in a time of 31 minutes 48 seconds, correct to the nearest second. Sam's average speed in this race is v kilometers per hour. By considering bounds, calculate the value of v to a suitable degree of accuracy, and you must show all your working to give a reasonable answer. Okay, so let's work out the bounds over here. So if the race distance is 10.6 to the nearest 0.1, then technically this could be 10.55 kilometers all the way to 10.65 kilometers. Okay, so that's how we write our bounds there. And then for the time is given to the nearest second, so this could be 31 minutes 48 seconds, but it could actually be 31 minutes 47.5 seconds, all the way to 31 minutes 48.5 seconds. So that's our, that is our bounds for our two measurements that were given. Okay, the next step then is basically you want to convert this into hours, because our race speed is given in kilometers per hour. Okay, so to convert this to hours, basically you would take the minutes and work out what they are as a fraction of an hour. So divide through by 60, and then take the number of seconds and divide through by 60 times by 60. Okay, and if you do that and then you add those together, you should get that your bounds are now 0.5301 so on, all the way to 0.5298 and so on. Okay, and then all you have to do is work out what the top bound for the speed will be and the bottom bound. So the speed, remember, is in kilometers per hour, so it's the distance divided by the time. And so to get the highest possible speed, you'd want the lowest possible distance divided by, to get the highest possible speed, you want the highest possible distance, so the max distance, and the lowest time, and that would give you the max speed. Okay, and so you can plug that in, that the max distance would be 10.65. So you did 10.65 kilometers in the lowest possible time, which you worked out was 0.5301 hours. and you put that in, then you should get a lower bound of about 20.09. Sorry, the lower bound should be about 19.900. And then you do the same thing for the upper bound, but you need to work out what quantities you need. So for the upper bound, you need the lowest possible distance and the highest possible time, okay? And that will give you sorry, this is the lower bound, the lowest possible speed. And so you can plug those in again. And so you just do the lowest possible distance, 10.55, divide through by the highest possible time, which you worked out was 0.5301. And so actually I made a little mistake in the top one. This should be 0.5298 and so on. And if you put that into a calculator, you should get 20.099. Okay, and so that's your upper bound and lower bound for your speeds. And so then we want to work out V to a suitable degree of accuracy. So basically, to what degree of accuracy are both of these numbers the same? So if you were to give these to two significant figures, and both of these would come out to 20 kilometers per hour, okay, if it's two sig figs. So that's what you want to give it to. If you were to go to three significant figures, then you'd have a problem, because this would be 20.1 and this would be 20.0, okay? Oh, sorry, this would be 19.9. And so then you'd have two different numbers, and so really you can only give it to two significant figures, otherwise there's too much inaccuracy to actually tell what his speed was, to any more accuracy than that. Okay, so hopefully that makes sense, and let's move on. Okay, so we have a circle here with an equation x squared plus y squared equals 12.25. The point P lies on the circle. The coordinates of P are 2.1 and 2.8. The line L is a tangent to the circle at the point P. Find an equation of L and give your answer in the form x plus by equals c, where a, b, and c are integers. So the first thing we can do is try to work out the gradient of the radius. And so the way we can do this is to take the coordinates of the point. Okay, so the point P lies on the circle, and we should also have the center of the circle. So according to our equation here, because we have x plus y, you'd ordinarily see x minus x1 and y minus y1 equals something, the r squared. And basically these numbers would give you the center of the circle. So in this case, the center of the circle, because there's no numbers here, basically these numbers are 0, so the center of the circle is 0. Therefore, we can then work out the radius of the circle would be at 0.00, and we'd have some other point P that's lying on the circle, which is 2.1 and 2.8. And so if we work out what, we'd have a radius over here, and we can work out the gradient of this radius, okay? So to do that, we just do the difference in y over the difference in x. So 2.8 minus 0 over 2.1 minus 0, and this should give you 4/3. So your gradient here is 4/3. Now the reason why we wanted to find this is basically we'd have a tangent to the circle at this point, and so if it's a tangent, that means the gradient is minus 1, is basically the negative reciprocal. So essentially this is the gradient of the radius. So the gradient that we actually want of our line L is going to be minus 3/4. So it's a negative reciprocal. Okay, so that's our first part. For the next part, we just need to complete the equation. So we have y equals minus 3/4x plus c. So we need to work out what c is, and we can do that if we plug in values for x and y. And we are given two values of x and y because we're given this point P, which is on the circle, 2.1 and 2.8. Okay, perfect. So let's just plug those in. So when y is 2.8, then x is 2.1. And then you can rearrange to find what c is. So if you put that into your calculator basically to find out what c is going to be equal to 1.225. Okay. Then finally, we need it in the form ax plus by equals c, where a, b, and c are integers. So we can rewrite this then, that y equals minus 3/4 x plus 1.225. And then essentially we want to rearrange for our form that we wanted. And so this would become 3/4 x plus y equals 1.225. And we did make a small mistake over here, that your c over here is not 1.225, and you should get a c of 4.375. And that's to do with the negative over here. Okay, great. So then over here, you can just replace this with 4.375. And we can do the same thing over here. And then you just need to find a multiplier for this. And so you can just try different numbers, but essentially if you multiply everything by 8, then you should get the correct answer. So if you multiply everything by 8, then 3/4 times by 8 should give you 6x. Then you get 8y. And then 4.375 multiplied by 8 should give you 35. And that's it. And that is the final question on the paper. So hopefully all of those questions made sense. Our workings out made sense. And if you've got any other questions, please do leave them below in the comments. See you in the next one.